Hello, class receiving students and teachers. You may be seated. Class and the receiving students, as usual, we have to recall or go back to looking at our previous lessons before we go to the new lesson. Now, for this morning, we will be revising on some of the terms that we looked at in the two previous lessons. Now, to do this, students in the receiving schools with your teachers, we will be using the strategy, find your other half. Now, I have 9 words, so I will have 9 students to hold the words up, and I will have the students, the other 9, with the definitions to find the correct words that the definitions go with. So I will have Doveri, Trisha, Edward, Violet, Nanadai, Adrian. If you can stand up, please, and move up quickly in front. In that order, how I call your names, you're going to hold the words quickly. Violet, between Edward and Nanadai, please. How many do we have there? Okay, let's have Raymond. Quickly. Patricia. Move. Terence. Quickly. Hold your words up so your friends who are sitting down can have a look at the words that you have. Now, when I give you the definitions, I'd like you to find your other half. Students who are standing, I'd like you to put your words right up so your friends can see it. Find your other half. Find your other half. You go and stand next to your half. Shane, I'm giving that to you. Okay, those with the words, I'd like you to find your other half, please. The ones with the definitions, you find your other half. Edward, your hands are blocking the word. Thank you. Get the word. Thank you. Keep on standing, and your partner moves back to her place. Once you find your half, the student who is holding the word, you move to your place, back to your place. Give it to him and you get it. The others who are sitting with the receiving students, I'd like you to have a look at what we have to see whether your friends have tried to find the correct other half. We still have first class liver there, effort distance, effort in a liver. The others, while you are sitting, check to see whether your friends have found the correct other half. Okay, let's have a look at pivot or fulcrum. I'd like you to, those students who are sitting down, you have a look at the words and their definitions. If you think it's not correct, I'd like you to raise your hand so you can tell us where it should be. Any word with its definition you think it's not the correct one? Any? Look at it quickly. You can talk about it with your friend. Those who are standing, please, you hold it up so your friends can have a look at it, as well as your friends in the receiving schools. Adjust it. Paul Simon, hold it up. Okay, we have Tulanga. Tulanga would like to correct one of the. Check quickly. Any corrections, please, students? Okay, let's see. Looking at all the definitions with their words, do you think they are all correct?
I think it's all correct.
So correct. Effort in a lever, effort distance, load, third class lever, load distance, first class lever, second class lever, pivot or fulcrum. Thanks very much. Thank you. I'd like you to put them back and you go and sit down. Teachers with the students, we are still on the same strand, same substrand and same outcome. Now, I'd like us to have a look at what I have. I have a seesaw balance. It's made from a piece of cardboard and a ruler. Now, I am going to put load on this seesaw. And we have two sides of the balance. We have one to the left and one to the right. Now, if I am to put a load on the left side of this balance, and to make this balance or to make the ruler balance, what will I do? Let's have Shane, please.
Get the correct distance or measure the distance between the objects.
Very good, thank you. Get the correct distance, have some load to be put on the other side that can balance the ruler. Now, when the forces on both sides, just like Shane has said, I already have some load which is on the ruler, and some more have to be put on the other side of a ruler. And once that happens, the ruler balances. Now, this is called the law of the lever. Law of the lever, we have to have both sides balancing the ruler or whatever simple machine is used for balancing. Our topic is the law of the lever. Now, definitions says the force times its distance are equal on both sides of the fulcrum or the pivot. So if you have a look at the diagram I have, we have 60 grams, which is our load on one side, and to balance that ruler or the simple machine, another load of 60 grams has been put on the other side. And we have the distance from the load to the fulcrum, which is 10 centimeters. So when we have both sides equal and they are balancing the simple machine well, then we have the law of the lever. If you can have the copy quickly, students receiving, in the receiving schools. Now, in this lesson, we will also be using some other words. And we will also be looking at the definitions of some of those words that we will be using. One of the words is mess. Mess. It says the force that is used for balancing. Now, mess is referred to as the load. We have been looking at that in our previous lessons. And the force that is used to balance whatever is on the seesaw balance that we are using, that is the ruler, is known as mass. But like I've said earlier, we use that, or we call it the load. Another term that we will be looking at is moment of the force. Moment of the force. Now it says the size of the force multiplied by its distance from the fulcrum or the pivot is known as the moment of the force. The diagram clearly shows that. The size of the force multiplied by its distance from the fulcrum. So we have the size of the force, which is 80 grams, multiplied by its distance from the fulcrum is here. So when this force, 80 grams, is multiplied by 11 centimeters, that gives us the moment of the force. Now we will also be looking at another word, which is anti-clockwise and clockwise. Anti-clockwise and clockwise are also used in the moment of the force. It says the moment of the force acts in two directions, anti-clockwise from the left side of the fulcrum and clockwise from the right side of the fulcrum. So if you have a look at the diagram once again, it shows clearly from the left side where the load or the force is to the pivot or the fulcrum is known as the anti-clockwise direction. From the right side to the fulcrum is known as the clockwise direction. No need to have that diagram, just have whatever it says there. Now our activity for this lesson, teachers, we will be once again using the strategy group work. You were asked to have the materials for this lesson, and I hope students, you have collected those materials for your teachers. Now, if you don't have those materials available, students in the receiving schools, you can observe what your friends will be doing in this lesson. So later, after the lesson, your teacher can go through the activity together with you and get you to do the activities. Class and the receiving students, our first instruction says you are to set up your seesaw balance, and we have the diagram that will show you how to set up the seesaw balance. Now, model class, you should have on your tables a fulcrum, a ruler, some cubes, plasticine cubes, and a piece or a bit of plasticine for you to use. Now, our diagram shows us how we should set up our seesaw balance. I'd like us to have a look at this diagram and try to follow that and set up our seesaw balance. If I can have the class to start now. If your ruler does not balance, put a bit of plasticine. So plasticine on the side of the ruler that is light so it can balance. Put it in the middle so you can all work on that together. Hurry up, move your hands quickly. Our time is running, so you have to move your hands quickly. Yeah. You have to make sure the ruler balances on that fulcrum you have. 50-centimeter line. Yeah? So you are pressing it right down. Don't press it down. It must be at that angle. No, not that. You have to use that piece that has been given, the piece of plasticine. This one, that one is not working well. That one is not working well. Give them this one. Check, are they okay? Is it at the 50? Check that one day. Now, before we go to carrying on with the second part of our activity, class and the receiving students, these are the loads that you are going to be using. 20 grams in your worksheet that you have, 20 grams, you will use 2 plasticine cubes. 40 grams, you will use 4 plasticine cubes, and 30 grams, you will use 3 plasticine cubes. Now, our second part of our lesson, or the activity, it says, put a 20-gram load on the left side of the ruler. And it must be 40 centimeters from the fulcrum. Okay, let me get it on there. Now, class, we are on with the third part of the activity. It says you put another 20-gram load on the other side of the fulcrum. Move it until the ruler is balanced. You should be all doing that now. 2 plasticines on the other side. Okay, then you are going to put another 20 gram on the other side. No, on top of it, on top of that.
On top.
Yeah. Which one are you doing now?
Number 2.
20-gram mess. How many cubes plasticine are you going to use? 2, not 3. Now, the other side, you also have to have another 20-gram load. And you will have to move it so it balances the load on the other side. Where is the other one? It should be 20 gram. See? You have to keep on moving it until you see it balances the...
Moving.
Fill this one up. Don't hold that one. Keep on moving until that one balances. Okay, that is how you are going to do the same for the other one. They got this done. Oh, you already got yours done. Okay. So the other side that you have put, that's the right side. Okay, the first 20-gram mess is put on the left side of the fulcrum. The second 20-gram load is put on the right side. Now, you're going to count from where you have put the load to balance the ruler and count the number of centimeters to the center or where the pivot is. And you write that over here, distance from pivot here. This one has been already done for you. Okay. How many centimeters is there? Okay, record it. You got this already. Did you get your first one done? Your first one already done. Can I see it? You're supposed to be filling this one up first. Not go into that. Here. You've already put the 20-gram load on the left side of the fulcrum. To balance the ruler, you put another 20-gram load on the right side. Now you count from where it balances to the fulcrum. How many centimeters you get, you record it there, just like this one here you have, see? So you have to do the same like this over here. You already go in there, you're not supposed to be doing it. Okay. But don't keep on holding it. Your left is dead. That's the load you already put it on. I'm explaining again the second time. See, that's the load you put it on already. Now you are going to, you were to balance this ruler with another load, 20 grams to the right. So you have done that. If it balance a ruler, then you start counting from where you put the ruler to put the load to balance. Start counting it to the 50 centimeter mark, and that number of centimeters you get, you record that over here. This is what you have to do. Okay, get that one done now. You have others to do, and you're going to do the same. Now you should have already done that fourth part of the activity to count up the number of centimeters from the fulcrum to the load. Record your readings in the results table. That is the distance from the fulcrum. You've already done that. If you haven't, you should be working on that. Distance from the fulcrum. Did you find your what? Good, you found it already. Okay. Then what you have done there, you do the same for the others. Don't forget.
80 centimeters. 80 centimeters.
Okay, what you have done for the first one, you carry on and do the same for the others you have here. Okay? What's that?
Are we finding the distance or are we finding?
Force times the distance. That's your force. Times the distance.
And then,
That's your force. Times the distance you get. You find the...
and then what unit are we gonna use?
What did you say? It's newtons.
Newtons.
Yeah. Don't forget you are multiplying the 40 centimeter by 0.2. So you should know something about maths. What do you do with that point there to get what? Now you should do... You haven't filled this one yet. What did you find from your measurement from the what? 50 what? Centimeters. So it should be recorded there and then you multiply it. Now once you have done the first one, you should do the same with all the other loads that you have.
This one should be at 30.
You on your second one, are you? Okay.
Should be at 30.
I'll just send him. Once again, you have to repeat what you have done with the first load. You do the same for the others. Students and in the receiving school and the teachers, we will do the first 3, and the next 2, I'd like you to get that done in your own time after the lesson. So, model class, I hope you are listening. You are to do the first 3. The first 3. You've already done the first one. I'd like you to work on the next 2. Oh, thank you. You're already finishing. Good. Do your last one. Which one are you on now? Okay. You should be doing your second one. The 40 gram. mesh from 30 centimeters. So you measure to your left 30 centimeters and your 40-gram mesh, which is going to be 4 plasticine cubes, okay? Then the other side must be also 40-gram load, 4 cubes. Then you try to work it out to see how you can get it done. Okay, let's see who has finished the first 3 or 2. First 3 or 2. We have Violet and her friends have already completed. Thank you. Okay, if I can have the class to put away what you are using, all your materials you are using, please. Put all your materials away. And if I can have you all sitting down. Thank you, Tulanga, Orvin. Now I'd like to get the answer from Violet and her friends. Violet and her friends, if they can tell us what you notice about the values on the left side and on the right side in the first times distance columns. The 3 you have done. Not the answers, but what do you see about them? The values that you have. It's talking about the figures or the answers that you have.
For the left is, it was, they measured the fixed distance. For the right, no, we had to move it back and forth to find the balancing point.
Okay, thank you. Now what I want to know once again is, looking at the first times distance, you have answers there for first times distance. You also have answers for first times distance on the right side too. You have left and right side. What can you tell about those 2 values? If I can have Rachel, thank you.
They were both the same, the first and the second. Only the third one was different.
Okay, thank you. Rachel says they are all the same. Now you are to write a summary report on your findings, receiving students. Teachers, you get your students to have that done in your own time. We will have the model class also to do the same. Now I'd like us to look at the table quickly, the first 3, as Violet and her friends. If they can give us again the answers that they have. Quarry, if you can give us what you have there. Your first one, first times distance for this and this. Left side.
8.
8. And
40 centimeter.
sorry, this one here.
8.
8. Now what was your distance?
40.
40.
40 centimeter. I'm right there.
Thank you. If you can give us the next one quickly.
12 newtons.
12 Newton. Your distance?
30.
30.
Same right there.
And your force times distance?
12.
12 Newton. Now let's see your third one.
8.
8 Newton. Your
45. 45.
45 cm. What did you get there?
9.
Okay. Now we haven't filled that in. Just putting 0.4 and 0.4 and also there. 0.4 and 0.2 and. Now that is the result that we have for those first three. Now if you have a look at the results, you will see that we have the force times distance on the left and force times distance on the right, which are same. So that shows us that the law of lever, whatever is on both sides, they have to balance, or they have to be the same. Now our summary for this lesson: the moment of a force depends on the size of the force and also the distance of the force from the pivot or fulcrum. Two, when the ruler is balanced, the clockwise moment and the anti-clockwise moment are equal. This is called the law of the lever, or the principle of moments. You should be having that written in your workbooks, model class, and also the receiving students. You should have a science workbook for keeping your notes in. So when we have definitions or notes like this to take down, you have them recorded in there. Our key phrase for this lesson is moment of the force. Our next lesson is going to be on pulley, and that will be the first lesson teachers in the receiving schools. Materials. We have the materials there. Now teachers, a reminder again we were unable to finish off the whole activities that the students were to do, so please, the next two mass or the load, I'd like you to work on that together with your students after your lesson is over, and when you have your materials ready with you. And with that, thank you, class, and the receiving students for your participation.